Okay, just the last little section of our revision of vectors. This bit here is just quickly dealing with geometry, our scalar product, and we're going to use that to help us find the angle between two vectors. So just to recall, if we look at this diagram here, let's imagine that we want to find an expression for RS. So if we're looking at RS, it's going R to S there. Remember, direction is very important. It means what we have to do is say this is going to be R O, because where we start from has to go there. It's not the other way around. So R to O and then O to S. So we can say that this is RO plus OS, noticing that these two are the same, and then the vector that we want is the outer over here. Now when we look at our diagram, RO is the reverse of R. So R is actually, I'm going to go fancy pants here, it's OR plus the OS, and OR is, sorry, it'd be minus OR because it's going the other way. So that's minus R plus S. Okay, so I know a lot of you could have seen that it was going to be the minus R plus S right from the word go, but I would like it if you could include your thinking, I guess, to show what's going on. Okay, and again, if we wanted to have a look at maybe S to T, okay, ST, that is going to be SO plus OT, and SO will be minus S plus T. Okay, so at least we've got this line here. That would be appreciated, and then we can go to that one. So that's a little bit of the geometry stuff. You can say one is half the other. There's a little bit of a question exercises I've asked you to do there, but pretty reasonable. Now the next thing is to remind you about the scalar product. I like to call it the dot product because it has that big old dot in the middle of it. Okay, so if I've got two vectors, we'll go back to our A and our B vectors. Okay, remember that A is A1, A2, A3, and our friend B, you guessed it, is B1, B2. And who knew there was a third bananas in pajamas, B3. So if I'm getting the dot product here, this is, remember, it's A1 times B1 plus A2 times B2. And that's where we would have stopped when we had the 2D vectors, but because we're now going 3D, it's nice and straightforward, and it becomes A3, B3. So the thing to remember here is with your scalar product, what you're going to end up with is a scalar. That's why it's called the scalar product. So you don't get a vector, you get a scalar. So if we're considering these two vectors here, we've got A dotted with B. That's going to be minus 1 times 2. So I'll write that. Plus 3 times 0 plus 4 times 3. And we end up with minus 2 plus nothing plus 12, which gives me 10. Now this means nothing. It means absolutely nothing unless it was to equal 0, because we know, or we recall, that when we find the dot product, and if it equals 0, then that means that A and B are perpendicular to each other. Okay, so that's a bit of a property that you want to make sure that you write down. Now, the other place where we find the dot product useful is in determining the angle between two vectors. And again, it's really nice that the formula that we used for the 2D, same for the 3D. So we've got cos theta equals the dot product, or the scalar product, of A and B all over the length of A and the length of B. Now, this is the angle that we're going to find between our two vectors, and you'll find generally that when we've got the dot product, when that is greater than 0, we will get this acute angle here. But when we work out our dot product and it is negative, right, so less than 0, that's when we have an obtuse angle. So that means that our angle will be between 90 degrees and 180. Now, speaking of degrees, when you are doing these calculations, you're going to need to make sure that you change your calculator back into degrees and not radians. Okay? And recall the video that we looked at last time. I'm not going to go through it every little bit of the way here, but when we go options, matrices and vectors, you can see that you can find your dot product between two vectors, and you've got this option to find the angle. I said I wasn't going to go through, but we'll just go here. We can go the dot product, and then again we go back to our original maths. We can pop in our oops, I did 2 by 2. We don't want that. We want the 3 by 1. Okay, pop that in, and what was our? It was minus 1, 0. Oh, sorry, I think it was 3 and 4. And then we just pop in our next one, which is 2, 0, and 3. We're going to close our brackets, and we get our answer here that we got was, oops, that was 10. And you'll do a similar situation. My calculator, you can see, is in radians. I haven't changed it back, so we'd have to go Shift, Menu, go down here, make sure you change it back to degrees, and then we could just go back up here, and instead of, so option, matrices, more, instead of the dot product, we can find the angle of those two. And it's an angle that's less than 90, which we knew because it was a positive value. So the next couple of exercises that I'd like you to do just plays around with that a little bit. So if you wouldn't mind making sure that that's done before we start term 2, that would be great. And of course, just send me a message if you get stuck on any of the questions that I've asked you to do.